begin with Dr. Miriam, who will be give us a 5-minute presentation about the space strategy for Africa in the context of her organization in Africa.
Thank you so much. Uh, Bon dia, good morning, everyone. Let me start my presentation for the interest of time. Um, I'm not the key person for the satellite space technology in the African Telecommunication Union, but speaking on behalf of my team on this topic today. So in the African Telecommunication Union, we have a department in charge of radio communication and space technologies as well. So as you may need, please next. This slide is for the young student. I know this slide is dedicated to young students, maybe to understand the key basic resources for the satellite. So mainly the radio frequency spectrum and orbital position in case of GSO satellite and orbit. Of course, this allocate this kind of resources in the mandate of the International Telecommunication Union, and to manage also these resources using international treaty known as radio regulations. And the demand for these resources is very high.
É muito alto na África.
Are facing some challenges. Next, please. So specifically, Africa is quite lagging behind in several, and we have several issues dealing with this situation, mainly the gaps in the radio regulation to ensure equitable access to satellite resources by the African members of the ITU, and also having gaps in radio regulation to provide adequate protection for resources allocated for developing countries. We also are dealing with gaps in the radio regulations relating to the acquisition and retention of satellite resources, lack of adequate resources by African countries to conduct satellite coordination and proper implementation of the procedures on the coordination and notification of satellite networks set out in the ITU radio regulation. And finally, these satellite systems. So the African space policy goals are mainly addressing the user needs, accessing to space services, developing the regional market, adopting good governance and management coordinating the African space arena, and promoting the intra-Africa and other international cooperation. African countries should consider the following satellite resources depending on the 4 thematic areas proposed in the African space strategy. The first one is the Earth observation satellites. The second one is navigation and positioning satellites. The third one is about satellite communications, including broadcasting. And finally, the space science and addressed by the space strategy in Africa. So as African body, we are having a key role in this strategy. First, to ensure the optimum acquisition of satellite resources, African countries should start by restoring their existing satellite resources in the planned bands, appendices 30, 38, and 30B, We had the case of two countries, namely South Sudan and Eritrea, who don't have resources in the planned bands. With the ITU coordination and the strong support from the ATU members states, the South Sudan was accorded a special consideration by the World Conference for Radio Communication in 2019, held in Sharm el-Sheikh. And of course, they get approval to submit to the administration of South Africa the necessary satellite resources. We have also have some key achievements done by the African Telecommunication, since we successfully recovered lost satellite resources for 31 African countries, combining them to participate in broadcasting satellite system, BSS. This was achieved through the implementation Sorry, I'm speeding for the interest of time. Okay. So the radio communication. Okay, because it's not working. Yes. So I was saying that the African Telecommunication Union, with the leadership of our Secretary General, managed to recover lost satellite resources for 31 African countries, enabling them to participate in the broad satellite system, broadcasting satellite system. This was achieved through the implementation of a resolution which lifted restriction against BSS in the geostationary frequency band of 11.7 to 12.2 gigahertz. The recovered resources are valued at $1 billion of US dollars. This is a significant achievement for Africa in the complex area of international satellite resources management by giving priority to the recovery of lost satellite resources. Africa has positioned itself as an equal player in the international arena and empowering the continent telecommunication and broadcasting sectors. In conclusion, in the unplanned bands, African countries could take advantage of satellite resources for the Earth observation satellites and new bands that are being identified in Q1 and V2 bands. The efficient retention of satellite resources can only be achieved if African administrations appoint dedicated staff and build their capacity to conduct proper coordination. The further steps should be made to amend the radio regulation treaty to ensure that satellite assignment and allotment in Appendix 30 and 30A and 30B
A recuperação com os apêndices.
With this, I will conclude my presentation. And thank you. I'll be available to your questions.
Okay, we'll just wait for Ms. Miriam to have a seat. So this presentation from Ms. Miriam was really to set and switch into Portuguese. Essa apresentação da
This presentation by Ms. Miriam was in fact for presenting a little bit of what the Organization of Telecommunication for Africa, ATO, has been doing to secure that the more countries could have communication satellites in orbit positions, and we will work on covering the African continent ever more. But then I will give this to teacher Daniela, because teacher Danielle has a particularity, which is being in the space industry in Africa for some time, and being here present working directly with a series of leaders of space agencies in Africa as part of her doctorate. Dr. Danielle, welcome to Angola. And one of the questions that I would like to pose to you: how do you see the growth of space in Africa, in our continent? How has we grown? Thank you. Good morning. Well,
To return to Angola for my third visit, hosted by Dr. Zolana Joao and the GGPN team. We are collaborating on a project funded by NASA to apply satellite data, which measures soil moisture, or the level of water in the soil, in the southern part of the country. Hopefully you can come later today around 3 o'clock. I will give much more detail on that project. Now I would like to respond to your question. I began studying the space activities in Africa in the year 2007 for my master's degree research at MIT, and I have been continuing to study since then. And I've learned much important history and contemporary activities. Space activities in Africa are quite old. I think today we are celebrating many new achievements, but I'd like to give credit to the emerging governments in the era of decolonization. Right in the 1960s, it is the period after World War II, and many countries in Africa are forming their post-colonial governments, and they are interacting with the United Nations. And two key issues are pressing on the world: nuclear technology and space technology. How will they be addressed in a manner that's safe for the entire world? I recommend you consider the history of a country like Ghana that started at that time an organization to understand atomic energy and nuclear technology, which has later become the home of their National Space Agency as they incubate as well. In Africa as well, there's long been a commitment to creating organizations that serve public government functions and intergovernmental functions to use satellite communication, satellite positioning, satellite remote sensing or Earth observation, as well as astronomy, all the topics that you mentioned earlier. They have been active in Africa for many decades. And we see a major acceleration in the 1990s because of a major technology shift, because around the world, universities and companies were interested in what is called now small satellite engineering. It is an alternative way to build satellites that seeks a process to use electronics that are not specialized for space and to build systems that can be done in an affordable manner. Right here in Africa, many countries were interested in this small satellite revolution. And in parallel, there was an interest in establishing space programs to operate national communication satellites. So countries including Egypt and South Africa were establishing space projects even in the 1990s. And you see other organizations that are not called space agencies, but they are remote sensing agencies, mapping agencies, telecommunication regulators. They're all working on space topics. As we move into the 2000s, you see more countries active in space, countries like Nigeria working on their first satellite projects in communication and remote sensing. And in the past, I used to say that I knew every single leader of a space agency in Africa. Actually now, it's too many. So no longer can I personally know each one, but I've visited many countries, including Ghana Nigeria, Kenya, South Africa, Mauritius, Angola. But we now have space activities and more formal space agencies in many countries. Countries such as Rwanda and Algeria and Morocco, they're also active in their space activities. Some countries are choosing to work on training engineers in the early career or senior engineers to build small satellites as a way to bring knowledge about the space missions to the country. Other countries are really dedicated to ensuring they can bring communication services and remote sensing services to the country. But these days, as you can see from the presentation you made to me, Deo, on the first day, there are so many countries in Africa involved in space. And I see two different models. One model focusing on bringing innovation, research, and technology development to the country by doing experimental projects for training and for trying things that are very difficult. For example, I give credit to Nigeria. They wanted to have a project where their engineers could do a lot of engineering. And the reality is, if you're new, it's difficult. So they called it Nigeria Sat X. And they said it's an experimental satellite. The engineers will work on it. Maybe it won't work, but they will learn a lot. This is a model that can be done. Other universities around Africa have done projects in cooperation with international universities. I work at MIT in the US. I also have an appointment in Japan at the Kyushu Institute of Technology. And they do many partnerships with countries across Africa to build student satellites. It's very interesting. Another model, I think what we see in Angola, is a government-led activity to ensure a national service. So with ANGOSAT 2 and with your plans for Earth observation satellite, Angola is focusing on ensuring that the government is providing an important national utility. I think these models both can exist. The experimental research-oriented projects for training and education, and the service-oriented projects that deliver a service. We see these examples in both Africa. I also study policies like these in the Middle East, Southeast Asia, and Latin America. And I think countries will continue to grow. The question also is, where do you see both public and private activities? Right now, we see the biggest private sector activities in the satellite development and manufacturing in South Africa. But I would like to note that there are many private sector activities in the services that provide analysis and answers to questions by building maps and communication services all over Africa. So now we see a lot of public sector leadership in space, which I think makes sense because in Africa, the goal is often to use space technology to meet the sustainable development goals or any of the agendas set by African leadership. And as we see the African Space Agency forming, it's allowing countries that have not yet formed their national space programs to also participate in these efforts. Thank you so much.
Thank you so much, Dr. Daniel. Temidayo, Dr. Daniel.
Dr. Daniel, she made, she spoke about what she followed as the evolution of the continent with the rising of new emerging in the special industry. Dr. Miriam previously spoke about the work that ATO has been doing with the name of protecting some scarce project, and it's important that all this activity can be sustainable. And for sustainability to happen, we need to have a strategy. And we know that the African Union have developed a special strategy for the continent in order for us to use it as a guiding project for the continent. Tumidai, can you give us a small lesson on what is the African special strategy, what's made up of, and what are the results that we expect from this project?
Much, Dr. Zolana. Before I continue, I'd like to say that even though I'm representing the African Union on this panel, I don't speak on behalf of the African Union. I'm just a consultant for the African Union. So don't take my words as statement of the African Union. So I haven't cleared that. So the African space strategies and policies, this is work that has been going on for over a decade now. As she said, African countries have been developing national space program for several decades. but usually it's countries working in different patterns, running different models, and developing different national programs. And one of the fundamental issues that we also had with different African countries developing national space program was uh, there was really no collaborations and cooperations among these countries. It was quite difficult for you know to see African countries actually cooperate and collaborate on national space program. It was also quite evident that some countries cannot just afford to develop national space program, but because the country cannot afford to develop a national space program, it doesn't mean that they should be excluded from making use of space and satellite technologies and data. Um, so for the African Union, it was all about, okay, let's bring African countries together, run continental-wide space program. This makes sense for a lot of reasons. It reduces redundancies, and it also brings countries that are unable to develop national space program into the conversation. Talking about redundancies, so give an example. If Angola launches an Earth observation satellite to provide satellite data for the Angolan region or the Southern African region, imagine South Africa building and launching the same satellites, providing the same data, and let's say each satellite costs about $10 million. You know, if that's a wastage basically, because Angola could just launch the satellites, share the data with South Africa, or the two countries can come together with other countries in the region to launch this one satellite, and everybody shares the data. So this is able to reduce redundancies, is able to facilitate cooperations among all of these countries, and this was the major problem that we're actually seeing on the continent because everybody was building satellite, everybody was launching satellite. Most of the satellites were providing the same type of data, and there was no satellite data sharing policy or infrastructures. Countries were not able to collaborate with each other. But the African space policy and strategy sort of like, it addresses some of these problems. So aside from the fact that it's bringing all of these countries together, it's also facilitating cooperation. And if you look at the strategy, it's in basically four segments. So there is the Earth observation segment, there is the positioning and navigation, as she has said in the presentation. There is the science and astronomy segment, and there is the satellite communication segment. So these are the four critical areas that the African Union have actually identified. And this is also very significant because this is a critical part of the African Union Agenda 2063. So, which is basically an agenda for the future that we want in Africa. So for African Union Commission, they've identified space technologies as a critical tool to build the future of Africa that we all want. And there are two major missions, for the entire African space policy and strategy. The first is development of services and products that are required to respond effectively to socioeconomic needs of the continent. And the second is to develop indigenous capacity to operate and maintain core space capabilities. So the fundamental thing is how do we use this space technology to solve our problems in Africa? And the second is, okay, how do we build the required capacity that we need on the continent, reducing dependencies on foreign technologies. Personally, I believe the continent can achieve whatever we set our mind on. So if we're able to bring everyone together, we can collaborate, we can share resources, we can share data, we can share technology and build things for the continent. And talking about what has happened in the last, in the last decade, the African Union set up a committee to work on the policy and strategy. This was worked on. This was accepted by the African Union ministerial panel and the policy has been passed, the strategy has been passed. There was a call for countries that want to host the agency. A couple of countries applied for this. Egypt was selected to be the host for the African Space Agency. The agency has now been built in Egypt. It's a massive structure that has been launched in Cairo now. For also the launch of the agency, $10 million has been set aside for initial operation of the agency. And in the next couple of months or the next couple of years, we expect that the African Union Commission will start hiring people that would work in this agency. But beyond the agency, there has been work has been going on to bring all of these countries together to sort of like build a template of what a continental collaboration would look like. An example of this is the GMS in Africa program that the African Union has been implementing since 2018 thereabouts. So this is a continental program that brought together 45 African countries. It's actually the largest Earth observation program that we've seen on the continent. So bringing all of these countries together, getting them to collaborate at institutional level, at regional level has actually been quite successful. So even countries like Chad or even Zambia, or countries that don't even have national space program, they've been able to even bring them into this fold. Presently, there are about just 22 countries in Africa that have either established a space program or in the process of establishing one. But the GMES and Africa program has brought together 45 countries. So this has shown a template for how a continentally driven space program would look like. And lastly, the African Space Agency does not disturb national ambition. So even though there is going to be a continental space program, Angola and other countries can still continue with their individual national space program. But the goal is that at the center, we'll be able to collaborate and we'll be able to share resources together. Thank you.
Okay, thank you so much, Timidayo, for this overview in terms of the African space strategy. The policy was approved. So, switching to Portuguese, sem agradecer o Timidayo.
I'd like to thank Timidayo because he provided us the spoke about the importance of the African special agents with headquarters in Egypt. It was invested 10 million US dollars to make it operational, and we have got a special African agenda, and this African agenda 2063 with some objective whereby the geospatial technology we have a fundamental role. We are at the middle of our session. We still have 45 minutes. I would like to go to the second round of questions.
5 minutos, 10 minutos.
Leave 5, 10 minutes so that the audience can actually prepare themselves to place ask questions to the speakers. And I will kindly request the support of the organization. Before I hand over the floor to Dr. Midian, Dr. Daniel, based on what Temedayo described on the African spatial strategy, and he speaks about the need to have at least 4 satellite categories such as communication, observation, science, astronomy in this case, and surveillance or observation. So what I'd want you is to advise us as Angola, and what are your recommendations based on your experience and based on what you have been able to observe? What is our next steps? What should we be focusing on based on your experience in the African continent?
Important is to learn from stories of previous projects in Africa. I have been fortunate to learn by interviewing many leaders who are creating new space agencies or leading intergovernmental projects in space. There's an interesting example in the past of a constellation, or I should say a cooperation, of about 40 African countries to come together to pursue a communication satellite project together. It was a learning process. I think it's a foundation for some of the things we see now that are bringing countries together. Not everything was successful, but I think the diplomatic work that was done to bring agreement among the countries to form a document and agree on a process to procure a satellite is informative. I also want to appreciate the series of meetings that have happened in the past, including the series called the African Leadership Meetings on Space Technology. They've been hosted in the past in countries like Kenya, South Africa, and Ghana. I also want to give examples of the different modes that countries have used to procure satellites. South Africa was able to build the first locally, domestically built satellite in the continent in the 1990s. It was built at Stellenbosch University and launched with cooperation from NASA in 1999. It was called SunSat, an example of these smaller satellites with shorter lifetimes. And we see many other countries learning by cooperating with either international universities, such as the projects done by universities in Ghana, like All Nations University, or universities in Nigeria, as well as government agencies sometimes work with international companies or universities. So we see in the case of Kenya, for example, they're cooperating with the Italian Space Agency. Mauritius is cooperating with teams in Europe, for example. I think all the stories from other countries are a lesson for Angola. You could ask, what was helpful about the model that a country used if they send students to a different university, if they make a contract with a foreign company or a local company, if they are working with an international agreement with another African country or with an international organization. Why is that particular approach useful, and what does it mean for Angola? You can ask the question, what are the priorities in the country? A simple example, when I first met you, it was clear that the country is focusing heavily on relieving the suffering in the southern part of the country related to drought. So this has been clear from 2019 when we first started to talk. So I think every country has to ask what needs and priorities are most important. Then ask, what is our political situation? What do the national leaders want to do in terms of building local skills, educational goals, and what do we expect will create sustainable interest in the space program? And from there, you can survey all these models of educational programs, such as working with foreign universities and local universities, research-oriented programs, commercially oriented programs, politically oriented programs. They're all on the menu for you. And I think you've had a chance to assess these and to make a choice. I think that decision-making and that analysis must continue, because things will change in the global market and in the domestic one. Another challenge I offer is to look at what's happening in the broader space community. Outside of Africa, we are seeing some new technologies become more commonplace. For example, at my university, we are able to cooperate both with US and international universities on sending experiments to the International Space Station. It means we can either send code, like software, to a robot that's already on the space station, and the robot can actually operate based on our code. Or we can actually send a physical box that has an experiment. We're studying, for example, beeswax. One idea could be to, in the future, cooperate on studying beeswax from Angola, because we're trying to see if beeswax can be used as a fuel that is non-toxic and naturally derived for satellites and space. These types of research opportunities are open to Angola as well, especially to prioritize education, innovation, and being part of the global body of innovation activities.
All right. Muito obrigado, professora Danielle.
Thank you, Professor Danielle. I'll give the floor to Miss Miriam. Miss Miriam, there are many scientists and decision makers and government representatives that defend that the only option so that Africa will no longer the less connected continent in the world is the use of communication is by resorting by communication satellites, and that is one of the means that will be able to accelerate and fill in this digital gap. Do you agree with this statement? And what is your take on this statement? Thank you.
Absolutely, I fully agree. And the role of the African Telecommunication Union is to address these challenges. The first mandate of the African Telecommunication is to promote the connectivity across the continent. And of course, the satellite and space technologies are very important to bridge the gap, having in mind that we have a big continent, we have Sahara, and this space technology is very, very important to achieve the SDGs. For now, the role of the ITU is to raise the awareness uh, uh, for the membership and to also provide support when it comes to develop regulation framework, when it comes to discuss at global level on the needs to have the adequate resources to develop the space technologies for membership. And the other thing, it's about to build strategic partnership and cooperation among members and among partners and stakeholders at global level. This is very important. So we are fully involved in the discussion at global level through the preparation of WRC. The next WRC will be held in Dubai this year, and we had several online and physical meetings with our membership and also stakeholders at global levels, because today R2 have 51 country members and more than 60 associate members from African companies and global companies that are involved in the development of special and telecommunication activities in Africa. So this is very important for us to reach also the digital transformation strategy goals that was adopted in 2020 by the head of state of the African Union, and with the key objective to connect the unconnected and develop the digital services and application by 2030, having in mind that the key objective is to connect 80% of the unconnected population in Africa. Thank you.
Muito obrigado, Ms. Miriam. Nós estamos a correr.
Thank you, Ms. Miriam. We're actually running against the time. We had 45 minutes, now we have 36. And since the panel is thinking of, we'll think of the closing remarks or the recommendations in 1 minute, I would like to open a space for questions and answers. So I'd like to find out whether someone has a question to ask, one or two questions, and then we'll give the floor back to the speakers. Actually, say we are in 36 minutes and we're only giving 45 minutes. My bad. So please identify yourself and indicate to whom you're going to ask the question. Good afternoon, everyone. I'm Garcia Mateos. And knowing that with a satellite we'll have better control of land, the best moment, and to find out the best moment to cultivate or to farm and collect the food. So I'd like to find out how the African Spatial Agency would help African countries to have a more robust economy, and what would be the strategy. One more question, that's it. Bon dia.
Thank you a lot for this opportunity. My name is Serafim Francisco. I would like to address some questions to our speakers. And I would like to know what are the strategy that should be implemented to help more the social economic needs in the continent, and as well what we can do to empower our education system so that the youth may embrace and be participating on it as actively members to change our continent. Thank you.
Thank you so much for these wonderful questions. What we will do, mudando. Tem só mais uma.
We have one last question. One last question, please. Please identify yourself and the question.
My question is for the African Union, or maybe even the African Telecommunications Union. There is an organization called RASCOM and a company called RASCOM Star. And for lack of a better word, I think they would need some love from the African countries at this point. And by the way, congratulations to GGPN, very successful launch of your satellite.
Yeah.
Ok. Muito obrigado para o Analytics. Vamos então fazer o seguinte.
Let us do the following. I'll start by Timidayo, and then I'll give to Dr. Danielle, and then please answer the questions, and also please use the time for the final remarks. I will start with Timidayo. Garcia asked the question, how can satellite help African countries to have a more robust agriculture? What would you be your advice? And then you also take this time to make your final remarks. Muito.
I think the question on satellite for agriculture, maybe Dr. Wood should.
Okay.
I would answer this question regarding how African Union would help with satellite sharing and things like that. So the fundamental thing is to have data sharing policy in place. So a data sharing policy would ensure that if an African country launches a satellite, they are actually able to share that data with other countries. So we've actually seen an example of this. So like Nigeria. So Nigeria, at some point, Nigeria started a data sharing policy whereby if anyone asks them for data from the satellite, they actually give it for free. So beyond the fact that they were providing, these are Earth observation data. Beyond the fact that for every institutions in the country, whether you're a university, a government institution, if you request for satellite data from the Nigerian Space Agency, they will give you for free. But they extended this to other countries in Africa. I think the problem is a lot of people are not aware of it. But if you need any imageries from the Nigerian satellites, you can actually request for it from the government and they'll give it to you for free. So the goal is to extend this type of policy across the entire continent so that, Angola is trying to launch an Earth observation satellite very soon. Angola should be able to share that data with other countries in Africa. But then to also get a centralized data sharing policy that can be implemented by the African Union. I can't comment on whether the African Space Agency would be launching any satellites in the next decade. I know this is not exactly a priority, but definitely if the African Space Agency launches a satellite, or if they implement any satellite program, whatever data comes out of that would be shared with all countries in Africa. One of the good things about the African Space Agency is that every country under the African Union Commission is under this. So as long as you're an African Union member, you're automatically a member of the African Space Agency. So, the data and everything is going to be shared with everyone. Even beyond the data sharing, we're also seeing fundamental collaborations because, as I mentioned, the goal of the African Space Agency is to get countries to collaborate. So if you've got companies or institutions in South Africa that are able to train people, how do we capitalize on that to grow manpower on the continent? At the New Space Conference in April, the Egyptian Space Agency Director General, he actually announced that in Egypt they have a satellite assembly integration and testing facility, which is a facility that you use to test satellites, to integrate satellites before you put them in space. And he announced that this facility is actually free to use for all African countries. So if tomorrow Angola decides they want to build a satellite locally, you don't have to build your own AIT facility. You can just take your satellite to Egypt to assemble, integrate, and test that. And this is the kind of collaboration and cooperation that the continentally driven space program aim to achieve. Is it
Your closing, very quickly.
yeah, I mean, my closing remark, again, I think the country is doing quite fine. We've seen a lot of progress with the Angola National Space Program. I think as you grow, you should also figure out what your niche would be. One of the things that South Africa, for example, is known for is, how there's a lot of private space companies, that are able to manufacture satellites, components, and technologies. And Rwanda, which also recently started their national space program, what they are trying to make as priorities to become the hub for space business. So, they try to create policies to attract companies to come and set up in Rwanda. So, as you grow in your national space program, figure out what your niche would be, and the values that you actually bring into the continental space program. Thank you very much.
Thank you, Temidai. Very quick to Professor Daniel. Houve uma pergunta ligado como podemos reforçar.
There was a question on how to reinforce the educational system and so as to enable the youth to actively participate and change the economic development in Africa. There was a question that Timadayo on how to use the satellite for agriculture to do that in a sustainable manner in Africa. And your closing.
I will try to be careful to cover each topic.
Yes.
First, I also want to thank you for the name of RASCOM. It is the project I was trying to remember a few minutes ago that was many countries in Africa cooperating on communication systems. I also agree. It's a question from Miriam. Thank you.
Okay.
I will take the agriculture question next. There are already many ways that satellite-based Earth observation is used to support agriculture in Africa and around the world. And this partly answers my recommendations to DG PIN and my answers for educational opportunities. It takes training in areas including hydrology, as well as understanding the biology of crops, to apply satellite imagery to understand what's happening with crops. One example program is called the Famine Early Warning Systems Network. It is led by the United States as a cooperation between NASA, our space agency, and our Agency for International Development. Now, you can ask the question, is it bringing enough benefit to countries in Africa? Perhaps not. There are about 25 countries in Africa participating, and maybe there's a need for space leaders in Africa to see what the results of the project are and to adopt locally more benefit. There is free data from NASA actually providing maps every month at fews.net, showing areas that are experiencing famine or drought. But maybe there's a need for more action by leaders in Africa to adopt such data and other international data sets showing agriculture and making it more part of local policies. This is also an example of the opportunity in the education area. Satellite data is wonderful, but it's complex to use. Please come at 3 o'clock, 3:15. I'll be speaking on how to use space technology to understand the environment. And we can discuss that there's many types of satellites with different categories of data. It's sometimes a picture like your cell phone makes. Other times it's a measurement of a different category of radiation, looking at microwave, for example. And learning to use this kind of data takes training, but this is an opportunity for improving the education at the secondary level, the university level, and the postgraduate level. And I recommend it can be done through cooperation with universities such as mine, as well as others around the world. And my final recommendation in closing remarks is to ask, and you ask what can be Angola's niche. I propose it could be a regional hub for cooperation within the southern and southern western countries in Africa. I note because I am very familiar, for example, in Kenya, they have the regional center for the mapping or research for development. It's a very powerful tool. Many countries are members across Eastern and Southern Africa. In Western Africa, there are several regional centers serving the French-speaking language and the English-speaking countries that are very strong to cooperate on using space resources and communication and also in remote sensing. I'm curious, I don't know, in the southern western part of the continent, I don't see as much cooperation, and there's an opportunity to go across language barriers and to create more regional cooperation, especially in remote sensing and communication services. I think it's a challenge for Angola.
Yes. Thank you, Professor Daniel. Miss Miriam, you're going to be closing our panel. Eu gostaria que
I'd like you to answer. I'd like you to answer the answer from Paulo Analytics should we give some love to Rascom? And I would want you to also finalize with your closing remarks.
Obrigado. As you may know, Rascom is an African company owned by African countries. And for now, this company is in a very competitive market.
Okay.
That's a big challenge for these African companies. It was playing a key role when they started having satellite services providing for Africa, but the competition put these companies some challenges, and now, for now, there is a need to review the business model and for African members to look at it as a new challenge, how to put this and push this African company on the market and give it a new innovative management, having putting resources, because it's very important to have human resources, means, funding.
Talvez, pelo tempo, o microfone rápido, só para a Miss Miriam poder concluir. Pode ser o que está a ser usado pela plateia. Okay.
Let's use the wireless microphones in order to save time.
Yes. Just to conclude, we have these facilities at African continent. We just need to put our efforts and our means together to provide for Africa the new technologies, the new services to bridge the gap. And of course, we have all the platforms through the African Union, through the African Telecommunication Union, to promote and to coordinate efforts and to bring countries together to promote these very important activities and services in the continent. And thank you for this very nice panel. Thank you.
Obrigado, Miss Miriam. Eu queria pedir uma grande
A round of applause for the three speakers that came far away to share their knowledge with us. So I would recommend to look at their profile, the profile of these entities. It's a rarity. It's scarce to find them. They're not there just by randomly. And They'll be here at Angotic, and they'll be at the AGPN booth. For those of you who'd like to see for further clarifications, please do not hesitate to reach out to them. Once again, a round of applause to them.
year with us, but it's part of scientific fiction. And we had Blade Runner and Exterminator. That was a great villain, and the second movie was the bad guy. The second movie became a hero. So, practically speaking, daily life was frustrating. And during that time, they used to say, or the other of the movie would say, this was a mere coincidence, but there is a letter for everyone to do IDM. So IDM used to and it was expensive. Just about $400,000, and for space, capacity, and processing. And the technology back came from that. Destroy machinery. So the technology back there. I did not have the capacity to execute and do the processing, and that's where we came the introduction of the uh, winter DAA winter. So we come with believing that the strategy of AI should be executed. And in the 90s, that practice was frustrating, and we started having winter DAA. Now AI is developing and being executed. And you know why? It's because the limit of artificial intelligence today is one of the biggest actors in these changes. So 1950, there was no computer. Transistor was just invented, and the transistor is the one that allowed the main authorization of all electronic components, including it helped in telecommunication and everything. And everyone knows how a computer is nowadays, and that happened in a gradual manner. So that's the information of the 90s. We need to use to connect to a network. We would call and use the mobile phone for communication, and there was no internet, but there was other things for us to connect it, and other networks, and the disk. So now I'm speaking about the actors of change, and this is the first internet site. People speak about ARPANET, but ARPANET is a military network. But we started with the World Wide Web. It's a project at the European Research Center for Nuclear Research. That was the first web page before 1993, and we would use it. In that time, together with internet, we would use the first web crawler. Web crawler was the first small program to browse page in the internet and index. It's from 1954. So together with a web, we would have a robot in order to make a research of information in the internet. That was also important for big data and data searching in the internet. And one of the biggest actor is a plague of graphic processing. It was used for the games, and but it also has other apps. And the first one for computers is for NVIDIA company, 1999. I'm speaking about NVIDIA because in 2015 it started as a company creating plague for games because it required a lot of mathematics. So it's a specific plague for mathematical processing, and the computer processing was used with general processing. With the other use of mathematical processing, they used that plague, and the games were entertaining. And in 2015, NVIDIA said, okay, that's interesting for machine learning, and then in 2010 they changed strategy, and 2015 in Rio de Janeiro Big Data Week there was a representative of NVIDIA of Brazil and say, okay, NVIDIA is not a company of small games, will become artificial intelligence company. Now it's a company worth of $1 trillion because of the strategy that they started in 2010, and in Brazil they announced in 2015. It had a success, and they're using duplex for graphic processing, for good computing and mathematics, for artificial intelligence, to increase the performance of artificial intelligence. And they can also use so a good evolution, not with iPhone that was a good evolution, but a smartphone. They have the capacity of processing of a computer at the palm of your hand. And it give a boom in the use of internet, because the internet could be used wherever you go, not only the computer at home or your company. And here we've got an important point. The big growth of internet, as you can see, the first side of 16 million users, 0.4% of the world population, December 29, 2005, and by the end of last year, 69% of the population with access to internet. So there are 5,444 million people with access to internet. So in 2012, Gartner used to say that the quantity generated by internet is creating problems, it's creating havoc. It's becoming difficult for us to manage. We are not being able to manage it. And that problem that will be known as big data later on, it was domesticated by 2012, mid 2012, but internet grew so much that we had to find a solution to keep the internet performance. That was the cloud computing. We distributed connection everywhere so that we can have connection. So analytic at BI is the business intelligence system, data warehouses, and they were in the company. These techniques were in the companies in the 60s, 70s, and 80s. And by using this system, that's what related in one system to the other and one reality to the other. And that resulted in the winter. In 2012, here at the page of our business review, and the idea is how to deal with the volume, to deal with the variety of internet, and they would do with the system of the company. I had a text with all the numbers, all the information. There was no picture, no videos, no music. We didn't have this type of variety. And the information was well cataloged. In internet, we've got text, and the text can be anything. I won't have a logic, no structured information. So there was a volume, a variety, and we'll need to process quickly. In 2012, a solution came about, and Gartner, when spoke about big data, it was in 2014, because after solving the problem, big data nowadays is everywhere. It was in 2014, became something new, and there were other elements besides big data. We talk about Internet of Things and content analysis and everything that's dealt with artificial intelligence. And cloud, they would use it, and we'll see why. So the processing of a big data volume, they use data computing. But how did we domesticate big data? How did we start using the huge amount of data? This technology to deal with data volume, this set of information was extremely important for us to be able to find problems that created a winter in artificial intelligence in the 80s, 70s, and 90s. How do you work with this data? What was the computing at that time? I had to process information, would send information to the servers. Those big servers, expensive computers that would centralize everything. And we need to use mainframes that were supercomputers, and that computing, and it would use for the main computers. So they would say, okay, the information is not here, but let's use it. Then we won't waste time, and is able to do it where the information is and do the processing. So that demanded new techniques, and we would have computing distributed, cloud computing, and from there was a big blow. The big blow that was given to the data is that I have a curiosity. This month of big data are generated with artificial intelligence. I asked my colleague to do a monster generated by big data, and here it is. But the big Street Fighter games, that's a Hadouken. Hadouken is this small elephant, and the technology that gave name to all these new ways of dealing with data together. They would deal in different way the data. They would use a technique for small quantity, and they use in a parallel manner various computers working together to give a solution, and not a supercomputer by solving everything that was expensive, and the price was reduced, and it would process non-structured data and at a good speed in answering, because I could use different computers by using one only. I spoke a lot about technical sides. Now I speak about our daily experience. Now, what are the work of the data? At the end, we need to process a huge volume of data. But we've got a volume of data, and we can look at the system of a company, the normal source of a company. Whoever works with the companies, we look at the operations system of the companies, and BI can also be the beginning and the source. And after we start using the standard that or techniques that get standard and create rules and redo the search and look at all this process, so that the results of all this processing can be interpreted and clearly an action can be made. So what can we do at the end of the analysis and action? That's what we call artificial intelligence. So here I'll show to you all an idea that came from Gartner. Here we look at the 4 stages. You need to understand what happening to descriptive analytic. And here we are looking at the human intervention. I make analysis, and after human intervention, I have to make a decision and take an action. And after we do the diagnosis, after understanding what happened, I'll try to understand why it did happen. And also, we have a lot of human intervention after going to the intervention decision. Here I'm at the analytical world. And now, since I know what happened and why it happened, so maybe I'll try to predict what will happen based on what I have in terms of history. And there I'll use a lot of statistical techniques, and nowadays they're all here trying to know what will happen. So I'll go to a decision, do the prediction, so what I should have done. So here we've got human intervention, and if I go to decision making, I send information there that the system helps to make the decision. And as if starts walking, and after becomes operational. So we use it, we do step by step, and it's difficult from leaving it directly here to the prediction phase. And here, as I was saying, there are a lot of statistical data with computing. So what we do or the science that deals with in assurance is statistic. So we're speaking about system that has computing techniques and the techniques of computing to deal with the data and distribute information and processing it. So here, so artificial intelligence is statistic plus computing. It's an idea plus we should not be afraid that okay, I want to work with this, but I have to be the genius of statistic. No, as more statistic intelligent is, the most important is for us to know all the details of statistic. But to say that there is statistic behind it, you will analyze the possibility of seeing what's the best decision, what the best chances for each work, and that's part of the algorithm solution that I have to use in artificial intelligence. I've got three types: learning, the supervised, what's being correct today, and unsupervised. That's what we call our limitation for today. And the supervised is, I can say, computer, this is the information I have. I have here all the statements, all the credit. There was a fraud, that one was possible, that one was not possible, and from computer it to process it. So I'm simplifying the process, and from there you make the prediction. And I won't say anything. I put the prediction there, and I have to learn and provide all the information so that the technician will know it. That's the general point of view. Now, speaking about two great fields of IE is machine learning and machine learning. They make the decision according to the data that I provide. The idea is to do the following. There's a good difference is without being programmed for that. So I provide the information, and from there, the program will see what's the best way. I don't need to program it. I don't need to program all the possibilities. And the other one is the processing of natural language. We see the introduction of the text correction, so translator, in type of translation. So we need to learn them to learn their language, including translating. Now speaking about machine learning, it is a technique that's used because it's easier to explain. So what happens normally when we do test with machine learning, we use some type of algorithm and we give us results and say, okay, how is it? And people say, okay, I don't know. But there are a lot of decisions that's easier to explain how they go there because they track to know why is that the algorithm reached that result. So that's a learning that's supervised that's easier to interpret. So machine learning is another point that is though that's an idea from 1950 and that nowadays is being executed. Today we have got computing to do it well. That's neural a network that's having a brain, the computer. They use that mathematical brain to make auto calculation as we get the information. So that's the idea of the brain, but they need mathematics. Now, deep learning is nothing more than a normal technique, but with a lot of steps here. They should have an entrance and one layer and one exit. And in that layer, a lot of mathematical work is done. So a lot of techniques, we don't need to know all the mathematics behind that. Just like an hammer or screwdriver. So I need to know how to use the hammer and where to use the screwdriver. Because if not, I won't be able to use it. If I put a screw, I won't hit the screw with screwdriver. So we should know how each tool is used and understand the reasons for it. And we should use it so that we can know how to process it. So deep learning.
Let's say I need to recognize a cat. Then there is a photo of a cat, and I say it's a cat because it's a supervised learning on depending on how it's going to be used. Then the most certain data are supervised. Then there's a layer that is, oh, how sweetie. So move a cat movement. Then they'll see possible cat movements. Each layer does each thing, and they complement. And then out of it, there will be an information. They will neuronia. There's a nerve. A great example of deep learning is the human movement recognition. My kid has a Kinect, an Xbox video game. They had a device that was not. We were not able to program all movements, so he used the machine learning technique. And there are various techniques working together so as to understand the movement that has been made, interpret it, and do an action because we're controlling the games with the body movements. And this field of knowledge is the human activity movement used in security cameras and other less amusing aspects. But it's a practical example. It has internet information on the kinetics magic. And within the deep learning, where the artificial generative AI, and then we'll get into the creative artificial intelligence, not just for text such as ChatGPT, but there's also imagery, and I've used it for imagery for just a show of the big data, and there's ChatGPT and DALI. It's a combination of some techniques, deep learning techniques, using a great amount of data, and by reinforcing big data, then it all has to do with artificial intelligence. I was talking about DALI. This student robot was generated with this tool. I asked it, please place a robot study, and they generated the image. And for those who are API developers, they can look into this. So I wanted to take you through this pathway so as to understand how to get here. What am I supposed to study? You don't need to do statistics, but we need to study, and you don't need to understand neural network. So we say big data as a fuel of artificial intelligence. Let me just give you some tangible examples. A first major issue on big data in favor of artificial intelligence, came from the artificial intelligence professor Feifel Readers, and you'll be able to find our webpage. It's closed for research, but it has 14 million images, and it has this print for that of a day ago. There's 14 million prints cataloged to train machine learning algorithm, so they can actually test their algorithms. She was even recognized IT Person of the Year. She has been working in favor of artificial intelligence all over the world, and she has this opinion when she says our vision, the vision of the university, in universities, that big data will change the way drives learning. And the other has to do with the supercomputing. Can you still recall when we were IBM Deep Blue won Kasparov? It's a supercomputer. So it won one person. That was unbelievable at the time, but it was a supercomputer. Then IBM Watson also won Jeopardy. It's not different from ChatGPT, which has a computer behind it. The only difference is that it has a high cloud performance computer spread out all over the world, and it does processing, and it has the big data part. And I was just emphasizing the clouds. It has 175 million parameters. That's a lot of information. It requires a lot. What I've recently read is that the fifth most powerful computer is ChatGPT, which was produced by Microsoft. It was well sponsored. For those of you who would like to deepen, we don't have time enough to get into details, but this deep learning AI, it's an Portuguese book on deep learning, and there you'll be able to explain the deep learning and many layers, neuron. It has, and I've learned. I didn't talk about the logistical aspects, which are pretty much easier. What I've learned from machine learning, there's Harvard. I don't speak English, and if you, for those of you who don't speak English, you can actually resort to this technology and help them translate it. And there are other places, because what is the aspect? The biggest secret is not just understanding. Whenever we work with data, is to prepare a certain data for a specific solution. So you have a hammer and you need to resolve the problem with a hammer. You need a nail. What happens is that I will have a one type of solution. I work on a solution. Let's say what I want to discover is based on number as my mathematical solution. I have the data. I have categorical variables which are text. What are the difference? If I say female and male, then I won't be able to get straight the average. But this is just to give you an illustration. What seems to be the problem? We need to prepare a number of data that must be analyzed for the tool to be used. Why am I saying all this? Because we will find data that are ready to be worked on. So I have a page for data science, which is called Craig and Nutt. They have data set that can be used for studies, and by using this ready data, we can also work on how to prepare ours. It's not just about playing around. We need to learn the logic. And so they launched their data, and but there are many sources of data. Angola Open Data. We have open data for Africa. I did get hold of a local webpage. We have the National Statistic Institute, MIFIM, Minister of Finance, and Central Bank of Angola. We have data from Angola, and also from all over the world, where we have the open database from the World Bank. So it's a source to do the testing. And there's also the clouding. There are many sorts of clouding. But here, the language. We have the non-SIPON. The language we use for the database is still very useful. We have Sazo's language, but many machine learning and big data solutions with our programming language, our scale programming language. Many things are in Python, and the language of statisticians. This language is kind of different from the conventional, but there's a lot of library for machine learning and statistical function in which we can just insert image, and they'll give you the results. So we'll kindly invite you for reflections on the need to start with the analytical journey, because it's an important step to get to the machine learning and artificial intelligence. We need to work properly. Some I used to be told that there's no such thing as a big data project. So we need to learn how to use the data, look at the available data to resolve the problems. So my invitation is the 2014 World Cup. German used the ASP system to study all players' movements. So they had a secret weapon apart from the coach and quality of players. They won. They won Argentina, but they traumatized us. They left a trauma to us because we were not ready for that. And I wouldn't want you to suffer just like we did. The condominium was gathered together to watch. And in a few minutes, we'll take a sip from the glass of beer, and how to explain. They used a software called Match Insight. Match Insight. So they had the artificial intelligence software to don't allow your company to be defeated 7-1. That hurts a lot. I had a German shirt. I no longer use it. I no longer care about that shirt. And this is just to share some data on the use of artificial intelligence. China and United States are struggling or fighting for the first place. But in Africa, Portugal is here, 23rd. Brazil is in 39th place. Here, leading Africa, we have Mauritius and South Africa. And Angola is here in 158th position. And this is the question. It's not to see whether it's good or bad, half glass or half full glass. There's still plenty, long way to go. We need to start from somewhere. So the idea is, let us start. Why is that? That's Nelson Mandela, a source of world inspiration. Everything seems to be impossible until it's done. So let us start. Let us training. Let us train. I'm not a genius, a statistical genius, but we need to start. We need to get moving, to get started. I'm here for 7 years. I'm here 7 years, so we together. If you want some support for the company, we have at stake, but that's a joint work as a country. All of us working together to place Angola, to get Angola at the same position as South Africa and Mauritius. That's my message. That's the story that I wanted to share with you. Now let us move on to the practical part with Dr. Leonardo. I'm in LinkedIn. Thank you for your time. Good afternoon, everyone. I'm Leonardo. I work for the National Telecommunication Institute of Brazil. It's a private and research and educational institute, and also works at information communication technology. And we have a academy and research area. We also have know-how, transfer know-how to the market. We are sponsored by a private company, and 75% of our budget comes from transfer of skills to the market. And I represent these areas, especially when it comes to the applications, Internet of Things, and I'll repeat, big data and artificial intelligence. I'm not going to talk about on what he has said, but I'll share an app among the various app applications we have of Internet of Things that is taking big data and artificial intelligence are smart cities. And this will also take place in companies, in our homes, to affect our lives. And some of these examples is to as with the smart cities. Is the presentation ready? I'm pressing, but it's not changing. Okay, so let's get started. Talking about smart cities as an application. Please do understand big data, artificial intelligence applied in a city environment. Here we have public management, and a lot has been said about innovation, sustainability, inclusion in public management. That is to have more transparency, well-defined policies, competitiveness, and innovation part. We talk about green economy, creative economy, sustainability. If we have to look at the environment, waste management, water management, electricity, CO2 emission, and social inclusion. And now, how do we get all this? The foundation is technology. Basically, we are talking about connectivity. In other words, how do we connect these services? How do we transform these digital services into data? And why big data? Because the amount of data is so huge, but all data alone is not enough if it does not generate information. And then there's also the issue of Internet of Things. So I have this very simple drawing, because most of us are not engineers. We don't have to get into protocols. Let us look at the public lighting illumination of a city. In my city, there's a project. We have a city of 40,000 inhabitants. It has about 1,500 public lighting posts. A small bulb. How do you know whether it's because it's if it's when it's supposed to be on, it's off. Then someone goes and replaces. How do you tell that company? The WhatsApp group says, but it's horrible. The services are horrible. And now we're having interconnectivity. Each bulb is connected to the internet. I'm not going to tell you how. There's a matter of protocol. And then I have a platform of management, telemanagement. And what does this mean? If the bulb goes off, I have this information in real time. So I generate data, and this data transforms into information. Then I do not need an ordinary citizen to tell me that the light is not on. Do you think of the amount of services that, if they are connected, the advantages that it could bring about? Do you think that a bulb or a light bulb could be a police? Could be a police. It could monitor the environment. Yes, it could. In each bulb, in this sensor, I could place a microphone that detects or senses noise. And when it senses noise, I can tell order to. So all this because it has a computer that is connected into a platform. I'm not talking about big data yet. I'm talking about something concrete. I'm talking about transitional IoT. So with a computer, I'll have information or generate information that light bulb is banned. Just give you an idea. Who pays this? Who pays the fees? And we citizens pay the fees, and they pay about 70,000 worth of electricity, and uh, and I'm reducing the capacity of that light bulb during dawn because there's a reduction of traffic flow. I can reduce this. I reduce about 30%. 30%, I'm talking about 50,000 50,000 reais per month and 600,000 per year, which can then be served to build a school. So in a smart city environment, we can actually save money and making this application interesting. So I'm talking about Internet of Things and a platform that controls lightning, public lightning. Another thing is what we call intelligent smart video monitoring, and they can have facial recognition and license plate reading. In my city, if someone gets into a stolen car, let's say they steal it from Amazon and they get into my city, they will be able to be detected. And this detection goes directly to the police saying that a stolen car entered Santa Rita through its cameras. They will be able to be intercepted in few minutes. So through a platform that controls the cameras. And these are transitional of IoT. The very same concept works for face recognition. If you have a criminal record in Brazil, since Brazil is a huge country, there was a problem with there was a time where the criminal would commit a crime in one state and then would flee to another. Now we have a national database of wanted people, just like any cars, they can be detected. Fleet tracking, tracking your fleet from the local government vehicles. All of them are monitored. I'm not going to get into details, but anyone listening, anyone listening, could please raise your hand if you're listening. Anyone listening? Anyone listening? Anyone listening?
Nos transacionais de IoT,
Anyone listening? English? Anyone listening? Anyone listening? English? Okay, thank you. So, what does artificial intelligence can do for on our behalf? Whether it was a pistol, and that information generated by a, a light bulb. So they say they'll start signaling if they an evil-minded person, if the lights start signaling, they say that someone is watching me. That's neurological, but automatically the platform verifies what is the nearest camera to that evil person, and the camera will direct towards that person. Everything happens in few seconds. Someone is shot, and cameras then will be directed to you. Then we have a video, a camera directed to you in the police station. And then they also can actually activate the nearest police patrol. And that is can be done in seconds. So the issue of the big data with artificial intelligence, you should be able to take automated decisions for common good. So in this case, that will be public security within a smart, connected smart cities. So as to look at those evil-minded person. Someone can shout, someone can speed up the car. All this can be detected through the biometrical aspects that will activate the camera and will track the car. So here we have technology, and I've seen that already working in China. which is a less liberal country in terms of human rights and issue of confidentiality, or what artificial intelligence can do. So we see a young boy with a woman. Someone detected the face, and they know the name, height, weight, and recognize that it was the mother, his mother. So it's not longer an alarm. It wasn't about a kidnapping. But they still, the artificial intelligence will still keep on asking, why is he not in school? So the educational system, with the health system, the artificial intelligence seeks that they have an appointment, a doctor's appointment. So they come into a convergence with the information that stating that he's not in school because he's with his mother and probably is going to a doctor's appointment. Now, how is it possible to do that? You must connect health with education and many things interconnected, and then you generate this environment of big data. And more things are becoming more connected. We're talking about trillions of devices that are connected in a few years. And this will bring more data, more information, and with artificial intelligence, we'll be able to take more concrete steps towards that. What I've just said to you, telemanagement, monitoring, electricity measurement, municipal fleet, all these connected, generating big data, and applying artificial intelligence. That is what Marcos just explained to you. So this is just some of the examples that we could mention on the use in companies, schools, government facilities, in all of our lives. You can be quite certain is that we'll no longer have privacy. We'll no longer have privacy. So in Brazil, we've been discussing that a lot because general data protection has been was passed. Whether we can or we cannot do. So if we're already providing data free of charge to Google, I mean, and people don't even recognize that. So this is just to show you on how big data with artificial intelligence could work. This is my contact details, and we can provide consultancy work. Thank you.
Ô Marco, acho que era isso, né? Não sei se alguém tem alguma pergunta, se vai ter alguma sessão de pergunta.
I don't know if there'll be a Q&A session. I don't know how much time do we have.
Cadê dos organizadores? Quanto tempo nós ainda temos?
É porque o pessoal tem utilização da sala, né? Depois, eu não sei aí como é que...
Tem a fome de todos os presentes, né? E a utilização da sala.
That you're hungry in the room. There was a colleague yesterday who asked me about the use in BI to use statistical techniques to predict data. You don't need to have an avalanche of information. Techniques such as logistic regression, that's today considered artificial intelligence. Linear regression is used for quite some time now, and you can use it with normal database. I used it and started using it with a normal database. And we can use what today we call artificial intelligence and using less data. You can say that big data is a lot of information, but you can have million and billion of lines, but also have millions of lines. It's not that small as we think. It's good because we got enough volume in order to train. So logistic regression, what we do, we've got a set of data, but the most important is for us to know what we want from that information. So if I want to know if there was a fraud or anything else, I can have this information, and that information classifier shows it. So that's what we use to train, because these techniques, they show the correlation, they have some problem. Everything is based on a normal curve, and when the curve is not normal, we use some techniques and statistics to make it normal and use the technique. That's how we use it. So having data and studying a bit about it, we should not understand everything. I don't understand well. I don't understand everything about statistics. So we can join to some explanation on. So, so this is the basis. We should know the average, model, and so on. So we've got a set of items that we will use with common data. We don't need big data. So I'll give an example on business intelligence. As you know, business intelligence. So what's happening nowadays is, how do we invest in a company? For example, I invest in stock exchange, and we get all the specialists who will be doing statistics to look at the data and to know what will happen in future. With blockchain, what is happening nowadays about the knowledge of the crowd. You know, you can get a company such as Walmart, for example, or various fashion of the world. With blockchain, you can use services where the consumers we provide an opinion on how the company is, and from there they'll come to conclusion that the knowledge of the crowd can be convergent for reality, comparing to the analysis of the specialist. See how disruptive it is. They can result in a decision of investing or not in that company. So we are speaking about business intelligence based on big data, statistic, and today with technology centered on blockchain, we can totally change the history of the game. So we've at this the tree of decision that was used in the, I believe it was in the 90s, to predict solution of the judge of the Supreme Court. So when I use these regressive techniques, I try to make correlation between the information, and correlation is a logic. Decision made by a judge, does not have a mathematical logic, but you vary. In the case of the U.S., if you're a Republican, Democrat, so what's the case? So what do we do? Do we get a set of decision and judge? Because judge of the Supreme Court, it takes time to change. So we need to study a lot of cases where the judge made a decision. But with three of decision that we showed with machine learning, they've mapped that situation that depends on the analysis. And, so when speaking about my computer or my robot was behave badly, so it's the data that you gave to him, and how did you reinforce his learning? So we speak about the butterfly effect. If you put something download something wrong to the machine learning, after you end up having a problem. So start mapping the points, and after you look at the percentage, and according to determine number, it will navigate in that tree. And I believe 75% of the judges they have had it correct. So what we do when you're doing the testing, we divide the information into areas: one to learn and one to see if the algorithm will know what happened. So we don't use that all that information that you have, but use half and another half. You see if it can result in what happened. It won't be 100%. So there we go. The best side of the history. When you speak about artificial intelligence, you gave an example of the judge. I'll give an example of the lawyers. The lawyers, they've got a way of creating a case, be it economical case or an other process. So with artificial intelligence, we'll be able to gather all the cases, a great number of data of cases, and change the lawyers. So that's one of the professions that we are talking about, that it's possible to be used in the future, that the lawyers can be substituted by the artificial intelligence. That's scary, isn't it? So the developers, they will ask, okay, what's the best language for programming? And they will use Google. I will copy the code and I put it. But now they're using other chat to find bug in code. Another joke is for EPT chat, such as Google. It gave us to give us a good answer. They need to ask questions. Some people don't know how to ask questions. So another profession is do with medicine. You go to the physician and you tell him what you're feeling and what does it do. They will make this exam and that exam and that exam. We make the exam and another will do it and we take to the doctor. The machine cannot do that. Can't you tell the machine everything that you're feeling? Do this exam, and exam. In the presentation, we see that is we have to do everything to adapt it to it. Now that there will be a lot of changes on the way that we live, the way we work, for better, for worse. Is there a question?
Acho que pode fazer a questão. Opa.
Ok, muito obrigado. Sou Evaristo. E tenho uma questão concernente à questão da inteligência artificial. Eu gostava de saber, parte da TISTEC, pela vossa experiência, qual tem sido o nível de aceitação para as empresas em termos de implementação de projeto de IA. Eu também fiz um MBA em Ciência de Dados no Brasil e quando estava fazendo o meu TCC, eu fui a um hospital para usar um algoritmo de aprendizado de máquina para prever vários tipos de câncer. Uhum. Só que as nossas instituições são muito assim, frio. Eles são fechados. Primeira questão, rolaram-me tanto, depois de 3 meses não me deram nenhum dado. Eu tive que depois recorrer ao Kaggle, encontrei um banco de dados e usei dois algoritmos, que é regressão logística binária, o Nice Bayes e o árvore de decisão para poder defender. E eu gostava de saber, e também em nível de implementação, normalmente a quantidade de clientes que a TISTEC já tem, que normalmente aceitam um projeto de IA. Muito obrigado.
Tá. Projeto de IA, de verdade, porque assim, a gente tem uma barreira, como eu disse, não dá para fazer o projeto de IA. Ele tem que resolver um problema de negócio e eu sou limitado pelos meus dados. Então, por exemplo, não dá para tentar sair fazendo um aprendizado não supervisionado. A gente tem que começar, né, até pegar a confiança na informação, a gente tem que fazer a análise. Então, o que eu tenho tido de dificuldade, tá? Porque, na verdade, todo mundo quer. Mas o ponto é aquela parte da maturidade analítica. Que dados nós temos? Tem um BI já? Se não tem um BI, vamos começar pelo BI. O BI é parte importante da informação. Né? Por quê? Porque no BI eu vou, primeiro, verificando a informação. Que dados nós temos para cruzar? Dá para fazer muita coisa antes de chegar na inteligência artificial. E assim, hoje, né, como eu disse, a árvore de decisão está sendo chamada de inteligência artificial, porque uma vez que eu faço o computador decidir sozinho, virou inteligência artificial. A gente já põe nesse ramo da ciência. Mas, quando eu aprendi, não chamavam de inteligência artificial, né? Agora que colocaram. Mas, então, assim, tem muita coisa que eu não chamo necessariamente de inteligência artificial que dá para aplicar. Aqui, a gente está usando regressão logística, regressão linear e árvore. É o que a gente tem usado mais. Na prática, machine learning, primeiro, né, a capacidade de processamento. Se eu usar a rede neural realmente puxa do computador, puxa muito. Então, assim, nem todos têm estrutura para isso. A gente tem que ver até por onde a gente começa. Geralmente, a maturidade dos dados não ajuda, porque, assim, se eu tiver dados com a qualidade menor do que eu preciso, e, às vezes, a qualidade dos dados, quando a gente quer fazer esse tipo de projeto, a gente junta dados de várias fontes. Os dados parecem perfeitos quando eles estão na fonte. Quando a gente junta, aí a gente começa a ver um monte de problema. Tá? Então, por quê? Porque eu não consigo cruzar os dados. Um usa NIF, o outro usa BI. Aí eu não tenho como cruzar, eu vou comparar por nome. Mas comparar por nome tem uma margem de erro enorme. Né? Então, são esses problemas que a gente tem na prática. E aí, o que a gente tem que fazer? A empresa tem que estar junto com a gente, entender que não é o consultor querendo enrolar. A gente apresenta dados, né? A gente sempre começa pela descritiva, mostrando como é que as coisas estão. Olha, essa é a situação atual. Tá vendo? Eu estou com esse problema, esse problema, esse problema. Vamos arrumar o cadastro? Vamos falar com a área de cadastro e ver. Uma parte que eu ignorei quando eu apresentei é a gestão de dados. A gestão de dados é a coisa mais importante, que é por onde a gente tem que começar. Tipo, quem vai dizer para a empresa, porque se uma área está usando o NIF, outra área está usando o BI, né? Quem vai dizer, tipo, não sou eu que vou dizer para a empresa, olha, vocês têm que ver. Resolve aí, vamos usar todo mundo NIF, vamos usar todo mundo BI, isso tem que vir da própria empresa, eu sou o consultor, né? Estou ali para dizer. Então, esse tipo de dificuldade, assim, né? Tecnologia, a gente fala da tecnologia, mas toda solução de tecnologia é pessoas, processos e tecnologia. Então, pessoas e processos de negócio. O negócio tem que estar também envolvido, né? A gestão tem que estar envolvida com a gente e abraçar a causa, porque os nossos primeiros desafios são esses. E eu não estou falando assim, os dados da minha empresa estão todos em Excel. Olha, se eles estiverem padronizados, eu já trabalhei com Excel e Access, a gente juntou tudo, mas a informação estava boa e a gente conseguiu fazer previsões. Mas juntamos, né? Tinha 700 e tal planilhas. Juntamos, estava relativamente bem padronizado, a gente teve pequenos problemas. Os NIFs estavam ótimos. Então, tá bom, consegui cruzar, consegui ver duplicações e tal, mas a gente precisa dessa qualidade dos dados, que às vezes só aparece quando a gente junta. E aí a gestão da empresa tem que estar junto com a gente para a gente conseguir evoluir, para usar alguma técnica de estatística para solucionar. Isso não é problema só de Angola, não. Quando eu trabalhei no Brasil também teve. É um problema sério. A gestão de dados tem que ser uma iniciativa da empresa.
Eu vou dar um exemplo, Marco. Lá no Brasil está acontecendo muito isso. Tá? A gente está tendo muita procura, inclusive você citou de hospitais, mas é um passo antes de inteligência artificial. Ainda não está sendo usado, não. O que eles estão fazendo é exatamente isso. Né? Você pega, por exemplo, um hospital grande, você tem vários setores com dados muito importantes, mas eles não se falam. Então, não tem como correlacionar. Então, primeiro, você tem que organizar a casa. Certo? Você tem que juntar todos esses dados, ver o que se quer fazer com eles, o que quer se extrair de inteligência deles, para que os gestores possam tomar uma ação ainda com inteligência humana. É isso que está acontecendo. Ainda não tem máquina, inteligência artificial tomando decisões de negócio para a empresa, lá pelo que a gente está vendo. Mas vai chegar lá. E para chegar lá tem que montar essa base antes. Mas o que já está acontecendo agora? A empresa que não está fazendo isso, ela não melhora os seus processos, o seu custo está ficando muito alto, ela está ficando para trás e ela vai sair do mercado. Então, a necessidade, olha que eu até falei na outra palestra lá, não faz sentido se não tiver dinheiro no negócio. Né? Por que as empresas estão fazendo essa transformação hoje? Hospitais, empresas, porque tem que fazer sentido, porque tem que impactar no custo dela. O gestor pergunta o seguinte, tá bom, para organizar os dados aí, para contratar a empresa do Marco lá, eu vou gastar $500 mil. Qual é o payback disso? Como que isso vai refletir no meu custo a longo prazo? É isso que ele quer saber. Se não fizer sentido, ele não faz. Mas por que está fazendo muito sentido isso? Porque o concorrente está fazendo, o concorrente está melhorando o processo, diminuindo o custo, aumentando a lucratividade, e ele está ficando para trás. Então, esse movimento hoje, no Brasil, tá um enxame. A gente tá faltando profissional para a gente contratar para poder ajudar as empresas, inclusive hospitais, a fazerem esse processo. Mas ele já está acontecendo.
Mas a procura, né, a necessidade da transformação digital tá crescendo aqui em Angola. A gente tem visto, isso é uma coisa do ano passado. Bom, a pandemia ajudou, né? Foi todo mundo preso em casa, isso acelerou a transformação digital muito. E agora, né, se mantém a demanda, um pouco menos, mas se mantém a demanda. Então, tá crescendo aí a demanda.
Marco, acho que a gente tem que liberar a sala, né? Que daqui a pouquinho tem outra
muito
apresentação.
Obrigado.
Né? Obrigado, gente, pela
todos.
atenção aí de vocês.
Obrigado.
Vamos junto.